Thank you very much, Neil. I'll just share my screen, and once that loads up. Are you seeing my screen now?
Yes.
Excellent. So thank you very much. I'm Donald Noble, based at the University of Edinburgh, and I'll quickly give an overview of the project and the software suite of tools. Firstly, at a high level, and then I'll go into more detail of a user story of going through the entire suite of tools. In terms of the DTOceanPlus project, this is as many of you may be aware, this is a 3-year Horizon 2020 funded project. It started in May of 2018 and runs to August of this year, with 16 European partners and 2 US laboratories involved in the project, as you can see the list of partners there. The objective really is to support the entire technology innovation process from concept to deployment of devices and arrays. This project is continuing the development of the original DTOcean software, and the idea is to produce an advanced open source suite of tools for selection, development, deployment, and assessment of ocean energy systems. The tools themselves are designed to cope with or to look at wave and tidal stream technologies, and these can be either fixed or floating devices. And the idea is to look at both subsystems, single devices, and also arrays of devices. And these are designed to consider the technology at different levels of maturity, from early stage concepts up to commercial feasibility and design. So most of the modules, as you will see, have this 3 levels of complexity, starting off at low complexity with simpler data and fewer inputs to give a quick analysis, and moving up with more complex data to get more accurate results. These tools can be run as an integrated suite, and I'll show you more on that in a minute. But each of the tools can be run standalone, and they're accessed via a web browser interface, and the tools can run either on your local computer or on a company intranet server. So you can install them once and everyone in your company can get to use them.
Donald,
at a high level, we have 4 main groups of tools. Today we're focusing on the first 2.
Sorry, Donald, can you switch off your camera maybe, because sometimes your sound is not so is interrupted.
Apologies, I will do that.
Probably it will help. Thank you.
So today we are focusing on the deployment design tools and the assessment tools. Deployment tools are for optimizing the array or device deployment, and the assessment tools are to evaluate these projects. We also have within the suite a stage gate tool to guide technology development, and there'll be more on that in next week's session. And finally, there's a structured innovation tool which will assist with the process of innovating both new and improved concepts. And then these are supported by a main module, which is the main user interface, and some data management tools, which Frederic will touch on later, including catalogs and the digital representation. As I mentioned, the tools can be used for 3 main areas: to design, assess, and innovate for ocean energy technologies. The diagram on the right tries to show the flow of information around this loop, because it's a continuous loop of improvement, and highlights some of the key user inputs. And I'll go through this process in a bit more detail on the next slide. But effectively, the design process is assisting with developing optimal designs of subsystems, devices, and arrays. The assessment can either be looking at the performance of these subsystems or arrays within the context of a site and a project, or we can assess the status of the technology development in the stage gate tool. And Finally, the innovation is facilitated by this structured innovation concept tool, which guides you through innovating new concepts and improvements to existing technologies. So I'll take you through quickly a user journey, starting off with the deployment tools, moving to the assessment, stage gate, and structured innovation finally. So the user first starts with designing an optimal device or array deployment by running through these tools in order. Firstly, starting off characterizing the site and the machine prime mover, then calculating the energy captured by the device, including array interactions, transformed by the power takeoff subsystem, and delivered to the shore. So that is kind of the energy chain in the three modules: energy capture, energy transformation, and energy delivery. Finally, they can design moorings and foundations to keep the device on station within the station keeping module, and plan logistical marine operations for both the operation and maintenance of the array. This gives the array layout and configurations, the design of subsystems, bill of materials, and more outputs. Next, they can assess the design parameters from this design using the 4 assessment modules in any order. And this results in a set of assessment benchmarks. By providing details of their technology and its development pathway, and also using the assessment metrics calculated by the assessment tools, the user can benchmark their technology within the stage gate tool, which results in a stage gate metrics assessment report. This might identify a need for innovation, and so they can use the structural innovation tools to guide the innovation process and identify these areas to further improve their design. And finally, they can update their design with this innovation and design a new array layout. So you can see it's a continuous process. So that was, oops, I think, oh, sorry, I forgot. The final point was that they can start with innovating a new or improved concept in the structural innovation tool, or assessing their technology development stage in the stage gate. So it's not the only way to use these, but it is this kind of loop. So that was all I wanted to talk about today. So I'll hand the floor over to Frederic.